In this video, we will discuss an example in which we will discuss the increasing, decreasing uh, uh, intervals, local maximum, local minimum of the function, and also together with concavity in the end, let's try to sketch the graph of such a function, right? So we want to discuss, so you see this is a nice application of calculus, right? We want to discuss the function of y equal to 4x cubed plus 3x squared minus 6x plus 1 with respect to let's see, right, the following points, increasing and or decreasing intervals, local maxima and or minima, concavity, points of inflection, and in the end, sketch the curve. Sketch the curve of this function. Now let's try to do that, right? So increasing, decreasing intervals, that's corresponding to the first derivative being positive or negative. And in the same time, we can decide you get a local maximum or local minimum at the corresponding critical points, critical numbers, right? So let's try to do that. So we start from find the derivative. So y prime is 12x squared plus 6x minus 6, right? Now we want to know when this is positive, when this is negative. Before you do that, you want to know where the zero is, right? And try to factor this 6 2x squared plus 1 minus plus x minus 1, right? This is 6 2x minus 1 x plus 1, right? So that is the after we factor it, right? So y prime equal to 0 when x is negative 1 or x equal to 1/2, right? The second factor equal to 0 implies x is negative 1. First factor equal to 0, you get x is 1/2, right? So that's the critical numbers. Critical numbers. So this is this function here. If you have a local maximum or local minimum, that will happen at either negative 1 or 1/2, right? So before we do that, let's try to decide on the intervals. This function is increasing or decreasing, right? So you have two critical numbers, which means this two number divide the interval into divide the real line into three intervals, right? You can see that it should be from negative infinity to -1, from -1 to 1/2, and from 1/2 to positive infinity, right? And and you can decide on this interval the derivative is positive or negative, right? F prime, right? Then you can decide the function f is increasing or increasing or decreasing, right? So from negative infinity to -1, you can see that both factor are negative. You can try a number -10, right? Both factor are negative. So its multiplication will be positive, right? Which means our function f is increasing on the first interval. And from -1 to 1/2, the second factor will be positive. First factor is still negative, right? So this is negative times positive, negative. The function is decreasing. From 1/2 to infinity, again here, both factors are positive. So the function is also increasing. So the increasing intervals are from negative infinity to 1/2, from 1/2 to infinity. Decreasing intervals are from -1 to 1/2, right? So also you can see that now let's look at f of 1, f of -1, f of 1/2, that's local maximum or like local minimum, right? So left side of -1, left side of x equal to 1, you get the function is increasing. The right side of -1 function is decreasing. So the function go up and down. So which means by the first derivative test, f of -1 is a local maximum. Similarly, left side of 1/2 decreasing, right side going downward, function value getting smaller, right side of 1/2 getting bigger, right? So in this case, f of 1/2 is a local minimum. You can evaluate these two numbers, right? So now we want to decide uh, the concavities. And before we do that, I try to evaluate. So f of -1, plug this into our function here, right? 4 plus 3 minus 6 plus 1. So this is, yeah, f of -1, right? Which is -4. Mm, -4 plus 3 plus 6, 10 minus 6, which is 6, right? So this is 6. And f of 1/2 is 4 times 1 over 8 plus 3 over 4 minus 3 plus 1, right? So this is, you can do the calculation 1/2. No, this is 2 over 4, 5 over 4, 5 over 4 minus 2, right? So this is -3 over 4. left side, local maximum, right side, local minimum, right? So now let's try to get concavities. For concavities, we need to get the second derivative, right? So y double prime equal to y prime prime differentiate the first derivative, which is 24x plus 6, right? So this is equal to 6, 4x plus 1. So y prime, double prime equal to 0 when x equal to negative 1 over 4, right? Now you can see that this negative 1 over 4 divide the interval into the whole real line into two intervals from negative infinity to negative 1 over 4, from negative 1 over 4 to positive infinity, right? So now y double prime, so this will be negative. Then y will be concave downward. This is positive whenever x is greater than negative 1 over 4. Concave upward. And also you can see that the concavity changes, right? Left side of negative 1 over 4 downward, right side is upward. So you have an inflection point. So negative 1 over 4, f of negative 1 over 4 change, right? So this is inflection is an inflection point. Now let's try to sketch the graph of such a function, right? Let's try to sketch the graph of this function here, right? So sketch the graph. Three special points: local maximum, local minimum, and what? And uh, inflection point, right? You have negative 1, negative 1 over 4, and 1 half. So at negative 1 over negative 1, you get local max. At negative, at 1 half, you get local, oh wait, should be here. So this is negative 3 over 4. So this should be 6, right? And also you need to figure out what is f of negative 1 over 4. Use your calculator, right? And that should be positive. Yeah, that should be positive. I'll just put it somewhere here, right? So this will be our f of negative 1 over 4. Give you a point here. So this is local mean. And we have intervals, right? From negative infinity to negative 1, negative 1 to negative 1 over 4, negative 1 over 4 to 1 half. So this is negative 1, negative 1 over 4, 1 half. Left side of negative 1, the function is increasing and also concave downwards. So if you try to sketch it, let's use black, the function looks like this, increasing concave downward. And from -1 to -1 and 4, the function go from increasing to decreasing, but still concave downwards. So if you sketch the graph look like this, right? And from -1/4 to 1/2, the function go from still decreasing, but concavity changes. Concavity change to concave up, right? So the graph look like this. On the right side, the function again go back to increasing, but still concave up, concave up. So the graph look like this. So that is a graph of such a function, y equal to 4x cubed. What's the function here? 4x cubed plus 3x squared minus 6x plus 1. And that's how do we sketch the graph of such a function, right?